with the sharing the PowerPoint. Give me a while. Where's my PowerPoint? Okay, let me share another thing. Some of you come to me and ask me what is specific gravity because I didn't touch it during the lecture. Okay, if you go and check your lecture notes is the main thing that you must read. Not the PowerPoint. PowerPoint give you a quick understanding because I need to present to you within that 2 hours, so I give you a quick understanding. But still, if you need to know the detail, you got to go back to the lecture notes. But then, of course, for example, the entire topic I never cover, then you can totally leave it out. But the basic thing like specific gravity, such kind of thing, it will be there. Oh, can. So if you cannot find specific gravity definition when you are asked in the tutorial, that means it must be in the lecture notes. So please go and refer to the lecture notes. What is specific gravity? Specific gravity, there is, of course, specific gravity for liquid. It is with reference to water. Specific gravity for gas, it will be with reference to air. And then, of course, you must know the density for air, density for water, respectively. Can. Those who haven't turned on the video, please turn on the video, or else if I call you 2 times, I'll remove you. But if I remove you, you want to come in back again, you can come in, but make sure you on your video. Okay. Ko Zhi Chiu, please on your video. Muhammad, what? Who is that? Muhammad, what was this? Muhammad. Sometimes your name too long, Muhammad. I cannot figure out what's the ending. Muhammad, is it? Is there only one Muhammad here? Muhammad. Hafiz. Okay. On your video, Okay, let's proceed. I shall share today's lab. Now, as you know, lab 1, last week lab 1 and this week lab 2, both are inside the lab test coverage. So therefore, please make sure you are familiarized with both lab 1 and lab 2. When I say familiarized, means that you understand fully what these 2 lab is doing, and then what each components means. If you are told to do similar kind of question, you will be able to do. Of course, the lab test will not be exactly what lab 1 and lab 2 is. It will be a variation. It will just asking you to apply the same technique that you use in lab 1 and lab 2. Okay. Of course, during the sessions, I'm not sure yet whether the lab test is going to be invigilated, but if it's invigilated, I cannot give hints during the invigilation. So therefore, during this weekly lesson, I might drop hint here and there. So if you try to come and attend my lesson, sometimes I drop hint, you're not around, then too bad. So I drop hint on and off here and there. Can? Yeah. So, okay, like C programming, everyone should be very familiar with C programming. It's a linguistic programming. That means you use wordings to do the program. So in C programming, you have if certain condition, then task 1, else task 2, right? So this is a if then else statement. Now, there is a for condition, do task 1. There's a for statement. And there is a while statement, while condition, do task 1. And there's also a switch statement, whereby you can switch between case 1 to case 10 or case 11, up to you. Right? So these are C programming. Of course, in linguistic programming, when you run, you got to clear all the error. If there's any error, you cannot proceed, right? And if there's warning, you may proceed. Likewise, for LabVIEW, LabVIEW is made in different way. It uses a graphical programming method. So that means whatever you draw is your program. Or it's not whatever you write. So there is no writing involved. So basically, of course, if you draw, there's some connection error, there will be a cross on your schematic diagram. And of course, those are errors. If there are errors, you got to solve it before you can proceed. Now, if there's warning, same thing, they will ignore and let you run, right? So similarly for LabVIEW and C programming, LabVIEW, we are only focusing on this tree structure for while and case, at least for our syllabus. So for for loop, you have similar to that of for do statement, which we call it the for structure. While loop, you have the while structure, and which is similar to C programming, while condition do task one. And then of course the case structure, which is actually the switch case statement, right? Now you notice that here is week 2, 2, 3. Actually originally was planned for week 2 for for and while loop, and week 3, which is today, for the case. But then because of the installation that took up the whole of week 1, so therefore week 2 was used for lab 1, right? So therefore this whole thing was pushed to week 3. But nonetheless, I'm going to say this is the first thing I'm going to drop. For the lab test, we are only focusing on while and for loop. There's no case. There's no case structure. So it's only for for structure and while structure. Can I make myself clear? Yeah? Okay, I'm going to do some loop structure before I proceed. Let me turn on my LabVIEW first. Okay. Now you guys should be able to see the back panel, right? Now, for the structure, how do I call it? If you go to the block diagram, if I right click, I will get basically all this structure coming out, right? So you have for here, while here, and you have case statement here. So for example, if I were to start doing the while first, okay, I pull out and I draw a while. So it is like a whiteboard. This particular while statement is like a whiteboard. So anything that you put, for example, I go and put a plus adder. I go and put an adder and put it outside the loop. So if you put anything outside the loop is not going to execute it. This loop is not going to execute it. So unless you put your symbol inside the loop, then it will be executed each time you run through the loop. So that's the basic thing about the loop structure in the LabVIEW, right? Now, if I try to connect, this guy here, for example, I try to connect it to the input, it shows an error, right? Cross means an error, right? So if I connect to the output okay, but input is error. So how do I resolve this thing? So it cannot take anything from the frame. It cannot take anything from the frame. So what you do is, in all your loop structure, you can right click at the frame itself and you add shift register. When you add a shift register, you realize that there's a bottom pointing arrow and a top pointing arrow. Now this bottom pointing arrow, it means that you can take the input from here. You can take the input from here. Okay, and of course you can put the output to the output of the output shift register. You can put it to the output shift register. Now everything is defined. So now everything is numeric real, right? Now why is it so that just now it cannot be done, but now it can be done? Now because anything that output from a adder, basically LabVIEW assume that it is real. So therefore, when you put a real to the output, it can accept. And okay, so the difference, how is this input and output being linked? Okay, what happens is when you start to input a number into the adder, you will add. Of course, there's another number which we haven't defined. You add, and then you come out a sum and go to the output of the shift register. Now, what happens to this output of shift register? You will pump it back to the input again, and you will add the previous value with the current whatever. So let's say, for example, I create another constant here. Let me see how to create a constant. Let's say I create a constant over here. Change to constant. So I create a constant, I put to, let's say, 3. So every time I go in, 0, let's say the first time I go in is 0, 0 at 3, it'll be 3 at output. Now 3 will not just disappear. It will come, go in outside the loop. You get loop back to the input shift register, and this 3 will become in again, and you add the 3 again, becomes 6, right, output. Then 6 will go out again. You go out and then get put into the input again. Then it become a 6 here, right? 6 you add with 3, then it become 9. So you continue looping, and you continue each time you go through it add with 3, which is your step size. It keep increasing and increasing, increasing. Clear? Okay. Of course, if you want to have more shift register component, you can add components. So you got 2 shift register. Now, when you add, what does it mean? It means that if the first one comes in here, the value will get transmitted into the input. But if the second shift register come in, the first one will get moved to the second one. You understand what I mean? So it shift down. That's why it's called a shift register. But if you don't need, you can remove that element. Or if you just want one element, then you don't have to put in the element. Now, so clear so far about going out and then feeding back. Now, if you put it to elsewhere, not to the output of shift register, whatever you send to the output of the loop, it will not get feedback. So that's as simple as that. Okay. Now I can put a constant here. I can create a constant here, and I put, say, 4. Now this 4 will only interrupt the loop, the first round. That means the first loop, the 4 will come in, because the subsequent loop there is a feedback. So if you let 4 still come in, then the shift register, or rather the loop, will get confused, because should I take 4 or should I take the feedback? So therefore, this 4 is only for the initial condition. It's for initial condition. That means the first loop, it will be using 4, but after that, it will not use it anymore. Okay, clear? So this 4 is for initial condition. Now you realize that there is one thing called the loop iteration at the bottom left, and this loop iteration is basically counting the number of loops that you're counting the number of loop that you are at right now. So for example, now is looping the first loop. First loop, we normally label it as loop 0, right? Then when it goes to 2, 3, when it goes to loop 3, you look at the loop iteration, it will show 3, a number of 3. So if you want to display this, you can create an indicator, and I call it the loop index, right? Now, if you go to the, of course, the front panel, you realize that the loop index is also shown in the front panel. So therefore, it will be there. Certain of the element, when you put in, it will appear at the same time for both. Now, when your wire is not straight, you don't have to go and adjust it. You just right-click. You just say clean wire. You will adjust it properly for you. So you don't have to worry about the positioning. Okay. Now, the interesting thing about this while loop is it will continue running. If you leave it on and then go and have coffee, have lunch, come back, your computer might hang because too much memory. Keep running and running and running and flooding your whole computer with memory. Right? It will not stop until it meets the exit condition. Now, this condition is you can see that it is stop if it is true. Now, if I put a Boolean high, which is true, then it will stop. Or if I continue if it is true, this is the reverse. If you put it high, then it will continue. So on and so forth. So if I try to, let's say I go to the front panel, I put a button switch. I go to Boolean, I put a button switch. Right? This is a button switch. I can turn it on or off. Right? This button switch, I can turn it on or off. So if I go to the block diagram, you can see that this Boolean button switch is here. I can actually connect it here. Now I can connect it to basically your exit condition. And I actually want it to be, if it is true, then continue run. If it is not true, then you go out of the loop, right? You go out of the loop. So the other thing I want to share is the wait, wait function, the timing. So there is a timing function here. Where is it? Give me a while. Timing function. So if you go to the timing function, you take out the wait millisecond. Now wait millisecond means that every time you go through the loop, it will, let's say I create a constant here, and I say 200. Now each time you go through, it will delay by 200 before it send the output out. And then you go in again, you delay by 200 milliseconds, and you send it out. The reason why we slow it down is because if you don't slow it down, your eye cannot see. And the computer is very fast. In terms of microsecond, it will just finish up the whole thing. So therefore, you put in delay just to see the action of this thing, right? The how this thing can be run. Clear so far? Any question? Can I have feedback? Because I cannot see you.
No.
No question. So far so good. Now, of course, I have put in the loop and a Boolean. It means nothing. I still cannot play with the simulation. So right now, if I move back to the block diagram, I add in some display. Or why not I add the display at the front panel? Let's say I add the display at the front panel. I add, say, a thermometer. That is one kind of display. I add a tank. That is another kind of display. I add a graph waveform chart. That is another kind of display. Now notice that when you put your waveform chart, please don't go and adjust the scale. Just leave it as it is. Then you just connect it. So when it's run, it is better. If you go and adjust the waveform chart, then end up it will be having problem of auto scaling. Okay. So if I rearrange my layout to be this way, I cannot move the Boolean. Why? Okay. So if I rearrange this way, and let me check. Did I miss out anything? So of course the three of the display must be inside the loop, right? Because we want to run it within the loop, so it must be inside the while structure. And then at the same time, I want to check using all this display the output here. So I connect to the display, each of the display. Right? I want to check and display it using this particular both waveform chart, tank, and the thermometer. Right? So that's my first connection, right? So if I try to run this guy, let me hide the control panel. Now, if I try to run, have a habit of trying to click only the single run, not the multiple run, unless you really need a multiple run, or else your memory will be flooded very soon. Now, if I click a run, can you see that it cannot move, right? Yeah, but by the way, you can change the scale by changing the property, right? So for example, the scale is up to 100. I want to go to 1000. So you can see that it moved to 1000. Likewise, the tank, I can change the property. I can move it to 1000 as well, right? And of course, the lever can be pulled. For example, the lever here, you can resize it, of course, and you can pull the lever up and down. But that's besides the point. So right now, if I were to run again, it doesn't run, right? Because why? Because remember just now our exit condition is only when it is the power switch, this Boolean, which is the power switch. If let's say I put it as a power switch, if it is low, then it shall exit the loop. But if it is high, right now if it is high, and if I run it, then it should run. It should run. So you can see that when it's high, I run it, the waveform is displaying continuously the loop calculation, and at the same time, you can see that the tank and the thermometer is also running. And also at the same time, you can see that the loop index is increasing, right? Every time you run, is increasing. Now, if I were to clear this charge by clearing data operation and I clear chart, and then just now you see is quite fast because it's the delay I put is only 200. Let's say now I put to 1000, means that the delay will be 1 second. Then I try to run the simulation again. Now you can see that right now the loop is slower, right? And the way it updates is slower because now it's every 1 second. Just now it's every 0.2 second. It updates a bit. So therefore, you can slow down the thing based on the requirement. You want to see how fast it is running. Okay? Can so far so clear? Can or not? Now, how do you exit the loop? It will continue running like that without exiting. So if you want to exit the loop, you just got to make sure your power is low and everything stops. The moment it's low, your loop index stop running, your waveform chart and your thermometer and tank stop displaying the change in the height. Clear? Clear so far? Can, right? Any question for this? Any question? Should be quite straightforward, right? Now, let's say right now, instead of using plus, I want to change this symbol to replace it with multiply. Then it becomes a multiply, right? I change it to a multiply. And then I go back to the front panel. I run again. But of course, before that, I clear the chart. Okay, before I clear the chart, you can see that just now the plus sign, you have a straight line, linear, because it's every time you go in, you add by a fixed number, right? So every time you go through a loop, you get add by the fixed number. But if I change I change the sign to multiply, let's see what will the wave shape be like. If I change to multiply, I cannot run because your power is still not on. So I basically click on the power and I run. Can you see that it is group coming out? But you can see that very fast your tank is being filled and your thermometer is being filled. And because it's multiply, it's exponentially going up. Right? It's a curve, right? It's a curve going up very fast, and even way faster. So it's like very huge number until you put a stop to it, right? So therefore, a multiplication is no longer a linear, it's a parabolic going up, right? And likewise, if it's a division, then it will be parabolic going down, right? Etc. Of course, a multiplication, if you use a fraction, then it will be parabolic going down. And then, of course, subtract, it will be slope going downward by the linear slope. Oh, can? So far, clear? Oh. So this is your while loop. This is your while loop, right? While loop. So while loop itself has a condition to exit. But if let's say right now I want to change this guy, instead of while loop, I want to change it to a for loop right now. Now you realize that if I change the entire loop to a for loop, what happened? You realize that the condition for exit is no longer there, right? Condition for exit is no longer there. So therefore, there is no need to have a condition exit. But however, on the top left-hand corner, you can see at end, there is a loop count. Now, if I put a number, create a constant, and I put to 30, what does it mean? This means that this loop will operate for 30 count, meaning starting from 0, it will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 29, it will stop the whole loop. So the stop condition right now, instead of depending on external factor, right now is a fixed number. So I count for 30 times, 0 to 29 is actually 30 times. I will stop the loop. So therefore, now the power switch become redundant. So I can actually delete off the power switch. Okay. So that is for the for loop. So if I go back to the display again, same thing. I can clear the data operation for the chart. I can also pull down the lever for the thermometer and the tank. It's up to me, right? Then I can start running, right? If I click run, can you see the loop is running? And it will run up to, pay attention that this guy will stop at 29. 29. That I'm still in the multiplication, so therefore it's exponential. But you pay attention to the loop. Here is it will stop at 29. Upon reaching 29, it should stop. But of course, depending on the number you put there, if you put 50, then you will stop at 49. Because the first count is 0, then 1. So you see, when you hit 29, the whole loop actually stops. Okay, let me go back and replace it back to a plus. Replace the numeric palette back to a plus. Okay, so far so clear. Okay, let me try running again. So for a plus, it will be a straight line. Yeah, can you see? Now it's a straight line. So the loop is still running. Now, if I were to turn on this switch called the highlight execution. When I turn it on, you realize that the number will comes in, right? All this number. So each loop, you updates this number, right? So this is for basically for troubleshooting purposes. So each time you turn on this guy, it will show you at every point of calculation what is the number. Take note that this is important when you are troubleshooting. Right now it stopped already because it hit 30 count. So if you haven't hit the 30 count, the number will appear, right? I restart the simulation. So the number will appear. So the moment it hit 30 count for the for loop, it will just stop, right? So clear? But of course, when you turn on this light, the operation will be slower because of the updating of the value at each point. But if you turn off the light, the speed will be faster. So usually I will not turn it on unless I need to troubleshoot. Can so far? Any question? Any question? If no question, then we proceed with the lecture notes, the lab notes. So you will basically proceed. For your case, you will proceed creating your waveform chart, your thermometer, your current temp, initial temp. Initial temp is your initial condition, which just now I put it at the left-hand corner, which is only run one time. And then of course your on-off switch, which is controlling your exit for the loop, right? And then of course you wire up this thing. This one give a detailed explanation again on the while loop, and then you will do it for the for loop as well. You do it for the for loop. Notice that for loop there's no more power switch, right? And then they explain here also the for loop. Now I'm going to also explain the case, even though the case is not being tested for the lab test. I would want to demo the case. Now the case is basically a statement that contains many pages. So if you create a case that has 3 pages, so by you can see the top center portion, there is a selector label. So this selector label is basically an enum selector. The reason why we attach an enum to this question mark is this enum property will get passed into this top selector here. So therefore, when you define your enum, this thing will appear, the content of the enum. So when you change your page, meaning that right now I am maybe in the while loop, I will display this while loop content. Now if I change it to for loop, then I will go to the second page, which is a for loop. Now if I change to empty loop, then I'll go to this page. Of course, each of these page you can define, but when you define your page number, it has to be very specific, meaning that the cap, whether it's initial cap or small cap, everything must be exactly the same, or else it will prompt an error to you, right? And then of course, in each of these loop, let's say you are in a for loop, you will try to put a string to tell the user at the front panel that you are in the for loop. So he know exactly that he is playing of the stuff in your for loop. And likewise for your while loop, if you are in your while loop, you can go to the case selector, select the while, then you will go to the page of the while loop, right? So now you're in the while loop, right? And then of course the while loop again has a string that tells the user in the front panel that they are using the while loop, and so on and so forth. Even for the empty loop, you got to put in an empty loop string, but this string must be consistent at this 3 point. All must be the same. Ken, I will demo the case. Then after that, I will allow you to go and do your thing. Okay, let me also demo the case statement. Now here, like I say, my enum, actually I define also, again, same thing like the lab, I define into while page. So when I select to the while page came out. When I select to the empty page came out. When I select to the for page, the for page came out. But of course here, I didn't use the input of the loop to output our loop. So therefore later when I run, I need to use a multiple run. But it's okay, I'm just demonstrating the case whereby you can switch between different page of operation. You can just change the page, right? So so if I go back to the front panel, after selecting each of these. Now if I put it in the empty page, if I run, of course the string will tell me that I'm in the empty page, right? So it says empty, empty, nothing get run. Now if I change the input here to, let's say, 2, just to be consistent for both of them. Now if I change my my loop to be a for loop, now if I do a continuous run, can you see that this gauge is running? Because right now when you run to 10, of course, is the maximum, it stopped there. But of course, if you want it to be bigger, you can change the scale to, let's say, 1000, then you will have a lot more, right? So therefore, if I run again, you can see that it is a very slow increment right now, right? So the for loop is running, but it is moving slowly, right? Now, if I now, instead of a for loop, I change to a while loop. You can see that just now the string was displaying for loop. Now, if I go to the while loop, what happened? Let me change the property of this tank to much more. Let's say 1000. Now, if I run the while loop, can you see that the tank is filling up? Maybe it's not so obvious, but slowly it's been filling up, because it 2 add 2 add 2 add 2. So each loop you go through, you add 2 and add 2. So by the time slowly you can see that the tank is filling up. So the interesting thing about this case is by switching the enum, I actually controlling different portion of my devices. For example, when I go into a for loop, I'm controlling the gauge. When I'm going to the while loop, I'm controlling to the tank, right? Because in the back is written in such a way that this tank is in my while page, and this gauge is in my for page, and so on and so forth. And of course, there's another empty. So, but to the user, it is transparent. They don't know what you are doing. Say they don't know that you put them into different pages. They just know that if I select while, the while thing should run. If I select for, the for thing should run. So that's the key about enum. Ken, also I'm going to I forgot something. Let me go back to this one. I want to share with you also what we mean by array. Can you all see the back screen? Can? Okay. let me insert a, let's say a for structure first. And I go to the front panel. Now, we talked about array before. We have inserted the array and it's an empty array. And let's say I want the numeric indicator, I just put in the numeric indicator. But if you want a string, of course, you put in a string, then it will be array of string. Now it's an array of numeric indicator. So again, like what I have shown you all before also, you can pull the array so that it is in length. But if you don't like this, you want to pull it in terms of height, you may also do so. So it depends on whether you want a vertical array or a horizontal array. That's really up to your preference, right? So that's the construction of the array part, defining it. Then, of course, array is important. Why I'm stressing it to you is because the lab test you will be tested on array. Now, array usually you don't put inside the loop. If you put inside the loop, it cannot gather data, because let's say when you are running through the loop, within this first loop, the only data that is output, you choose any point to connect, you can only have one fixed data point, right? But if you go outside the loop, it's different. Each loop you go through, you have one point. So therefore, you can have a series of points, right? You can have a series of points. So let's say, for example, right now, I, again, go back to the same question. I put an adder, right? Let's say I put, again, a shift register. And then I put this guy to shift register using the same example I did just now. Now I want to monitor this as an array. So I just need to connect this guy all the way to the array. I don't have to go through the shift register. I just need to pump it directly through. You realize that if I clean the wire properly, it should connect properly, right? You realize that it is no problem, right? It can be connected. So if I put create a constant and I put, let's say 2, and I put a constant also here to 2, right? So if you run, it basically can run. And of course, this being the for loop, you can create a constant as well as, let's say 50, right? So it will be a 50 count. So each time you look through your 2 plus 2 plus 2, and then you can actually track this using an array, right? So if we try to run this, on the top, just to show you. If I try to run this on the top, of course, which are the few things that will run? This one is in a while loop. The while loop will run, and at the same time, array is not inside their loop. So array will also run. So can you see the array is filled up? Oh, it's very fast. Why? Because 2 plus 2 is 4, then 4 plus 2 is 6, 6 plus 2 is 8. So therefore, you can see that the array is being filled up very fast. Now, if you don't change this. If you change this to the first one, then it only display the second data. But if you go back to the first one, the first data is display the second data. So if you put it to the third, the first one that begin will be the third one. Can? So that's how your array can be used. And also, now if you, let's say you connect this and you have an error, right? So for example, you are not in indexing mode, but you are in the last value. Now last value means that you only take in one value and you don't store the previous value. So this array will make noise. They say no, because I'm looking for a series of number and it just give me the last value. So it doesn't match, therefore it's an error. So what you need to do is come to this square point here, right click, go to the tunneling mode, go to indexing. Now the moment you go to indexing, it's beautiful already. It can display the array. Can? Any question? Any question? No question. So it's pretty straightforward. So now you can proceed with your lab. Let's see. And then of course, once you finish, you may want to demo to me your for loop and while loop. I no need you to do the case because it's not tested, but I need you also to do the exercise 1, 2, and 3. That's to practice your array. At the back of the lab sheet, there's 1, 2, and 3. Okay, so try to do for and while. If you can finish before time, you can show me that you can get it working. Then you may leave. After showing me, of course.